Hello, everyone, and welcome back. Today, we're going to be going over rational root theorem, and we're going to be answering this question on finding all the real solutions to this polynomial here using the rational root theorem. Now, something else before we get started, I just want to note is that we're also going to be using other techniques like factoring quadratics in order to find all of the real roots, in addition to using the factor theorem and remainder theorem. So if you are unfamiliar with factor theorem and remainder theorem, there are other videos on those in the Algebra 2 series as well. But let's get started. So what's the rational root theorem? It tells us that if f of x is a polynomial and it has integer coefficients, then every rational solution of f of x is equal to 0 has the following form of p over q, where p is a factor of a naught, which is our constant term, and q is a factor of a n, which is our leading coefficient. And so our question asks us to find all the real solutions of this cubic function, x cubed minus 8x squared plus 11x plus 20 is equal to 0, using the rational root theorem. So the very first thing I need to do is I need to check that we can actually use the rational root theorem here. So I need to check that this is a polynomial that does only have integer coefficients, and that's true. I don't see any coefficients that are non-integer coefficients, and this certainly does fit the definition of a polynomial, and so we're good to go. We can use the rational root theorem. My next step is I need to find out what is the constant term, what is a naught in this situation, and also what is a n in this situation. And then I need to figure out what are all the factors of both of those things. So our leading coefficient in this case is just 1, because we just have 1x squared, or sorry, 1x cubed right here. And then my constant term is at the end, it's 20. So 20 is my a naught term. Then what I need to do is find all the factors. So just in brackets, I'm going to put all the factors for both of these. For 20, we have plus or minus 1, plus or minus 2. 3 would not work, so we'll skip that one, but plus or minus 4 would. Plus or minus 5, plus or minus 10, and plus or minus 20. Then we have our leading coefficient, and that's just going to be plus or minus 1, right? 1 is 1 and negative 1 are the only factors of 1, and so we're good to just stop there. Now, keep in mind that all the real solutions must have this form of p over q. So of one of these factors of 20, one of these 12 factors here on this first list right there, over one of these factors. And the thing is, dividing something by plus or minus 1, well, if we divide anything by plus 1, we just get that same thing back. And if we divide it by negative 1, we just get the negative version, right? Or the version with the flipped sign, where the sign changes. And so essentially what's happening is we're just going to end up with all these same factors of 20 for our possibilities. So the possibilities we have are just these numbers in this case. Are just these numbers, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20, right? Because essentially we're just taking all these, dividing them by 1, which gets us the same thing, or dividing by negative 1, which flips the sign, but doesn't actually give us any different values than we necessarily already had. Okay. So next, we actually have to figure out what these solutions are, because as we know, there can't really be 12 solutions. Not all of these possibilities are going to work. It's just that whichever numbers it ends up being is going to be from this list, essentially. We also know that because this is a cubic function, that means the maximum number of real solutions we could have would be 3, right? Because the maximum number of real solutions we can have for any polynomial is equal to the degree of that polynomial. So there's going to be either 3 solutions or less than 3. There could be 2 or 1 solutions as well. Okay, so let's go ahead and talk about how do we actually find those solutions. Well, let's let f of x be equal to the polynomial we have, like that. And then I need to figure out what I can put in here to get a 0 out, because recall that when f of k is equal to 0, that means that x minus k is a factor. And essentially, if we found a factor, we found one of our roots, right? And so we need to choose one of these to, in order to get started on this. So that's what I'm going to do. I believe that I think x plus 1 is a possible factor potentially. Just looking at these numbers here, I think that could be the case. Let's check and make sure that that is the case, though. And that's something I do advise you to do, is to actually take a look at it and see what looks like it might work, as opposed to just randomly starting from some random place, trying something, because we could be here all day if we do that. So take a look at what you think is probably going to work, and give that a try first, because oftentimes you'll be right. So let's do that. F of negative 1 is equal to negative 1 cubed minus 8 times negative 1 squared plus 11 times negative 1 plus 20, which is equal to negative 1 minus 8 minus 11 plus 20, which is equal to negative 20 plus 20, which is equal to 0. So there we go. F of negative 1 is equal to 0, which tells me that x minus negative 1, or x plus 1, is a factor. Okay, now I'm going to use synthetic division in order to actually figure out what we have left over. If you're unfamiliar with synthetic division, there's a whole video going over that as well. I will go over it here briefly too. Okay, so what we're doing is we are going to divide x cubed minus 8x squared plus 11x plus 20 by x plus 1. So I'm going to put negative 1 here, and then I'm going to write my coefficients up here like that. Then I'm going to bring down the 1 and then multiply. So negative 1 times 1 is negative 1. Negative 8 plus negative 1 is negative 9. And then I'm going to multiply again. So negative 1 times negative 9 is positive 9. So 9 goes here. 11 plus 9 is 20. And then I'm going to multiply again. So negative 1 times 20 is negative 20. And negative 20 plus 20 is 0. And keep in mind that whenever we're doing this, we should always get a 0 here in these kinds of situations, right? If we believe something's a factor and we do synthetic division or long division, then we should get that the remainder is 0. So if we don't get a 0 here in this specific type of case, that means we've done something wrong. Now, if we're just asked to divide something by something else in general, that doesn't necessarily mean it's a factor, but when we're already expecting it to be a factor, we need to make sure we do get a 0 there. Otherwise, there's been some mistake at some point. Okay, so there we go. That tells us that f of x, right, it's originally x cubed minus 8x squared plus 11x plus 20, that is equal to, or actually let's write it over here, that is equal to x plus 1 times x squared minus 9x plus 20, like that. So again, I'm just taking these coefficients and using them. And this 0 is referring to the remainder, so it doesn't need to be included as a coefficient or a constant or anything. And then the last step that I'm going to do, or pretty much the last step, is I'm going to continue to factor this even more so we can find out what those other real roots are. Now, we could factor this way again, but because we're down to a quadratic, it's probably easier if we just use our quadratic factoring methods. That'll probably be faster. So for this one, I'm going to see, can I find two numbers that can multiply to 20 and add to negative 9? And yes, those numbers would be negative 5, negative 4. So therefore, I have x plus 1 times x minus 4 times x minus 5, like that. And therefore, I've factored this, and my zeros are x is equal to negative 1, x is equal to 4, and x is equal to 5. And that must be all of them, because again, the maximum we could actually have is 3. And notice that those go along with the possibilities perfectly. Both all three of these, negative 1, 4, and 5, are included in those possibilities. If we get roots that are not included in those possibilities, that means there's either something incorrect about the possibilities that we wrote, or there's something wrong in the steps we took after that. So that's kind of the nice thing about this, is it all rounds out. It all rounds out in the end. Now, this was a big question. There were a lot of things we did. We had to do remainder theorem. We had to do synthetic division here. We had to use a quadratic factoring method. And we used a new theorem we learned called the rational root theorem as well. So as always, feel free to ask any questions you might have in the comments, and we'll see you for the next one.